1.3 Trigonometric functions. The first thing that we're going to talk about today is the Pythagorean theorem. The Pythagorean theorem is a way to find a missing side of a triangle when we're given two of the three sides. The formula is a squared plus b squared equals c squared. And when we're using this, c has to be the hypotenuse, which is the side that's across from the right angle. The other two sides are called the legs, and it doesn't matter which one's a or b. And as long as we have two of these three sides, we can find the third side by using the Pythagorean theorem. The next formula is the distance formula. The distance formula is a way to find the distance between 2 points on the coordinate plane. And that formula is right here. D is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So if you have 2 points, xy and xy, if you take the two x's and subtract them and square them, and then you take the two y's and you subtract them and square them, the square root of the sum of those two would be the distance between the 2 points. Now, the distance formula is actually related to the Pythagorean theorem. If I were to take the Pythagorean theorem and solve for c, if I took the square root of both sides of the equation, well, the square and the square root would cancel each other out, so c would equal the square root of a squared plus b squared. And see how this is the same as the distance formula. So we're going to be using that information in just a little bit in solving trig functions. Trigonometry means the study of triangles, and trigonometry is the relationship between an angle and two of the sides of a right triangle. So to define the 6 trigonometric functions, we're going to start by drawing an angle in standard position whose terminal side lies on a given point P, which will be defined in just a moment. Okay, so these points here, we have 4 separate triangles. So let's just look at this first triangle. So we can create triangles in any of the quadrants. And say if this is point P, this is an angle that's in standard position, where this is my initial side and then this is my terminal side. All right, so like I said, we can have a triangle in any of the quadrants. So this would be P for this triangle, this would be P for this triangle, and this would be P for this triangle. And you see how they're all, no matter what quadrant they're in, they're creating right triangles. So if we focus on just this one in quadrant 1, then this right here would be my R, which is my hypotenuse. This is my, whatever P is, that point, that's X, Y on the coordinate plane. So the coordinates of that point is going to be how far it goes on the x-axis and how far it goes on the y-axis. So we have 3 sides of the triangle: our x value, our y value, and our hypotenuse. Say if we were looking at the triangle that's in quadrant 3. This is my x value, this is my y value. So if we're given this point, P, so my x value is going to be negative, my y value is going to be negative, and then so I have an x, a y, and then I can use the Pythagorean theorem to find the hypotenuse, which is r. So that's how we're going to be looking at these different trig functions. Now, the ratio of these different sides of any of these triangles that we choose, like I said, we have these 3 parts, and the ratios of those parts give us the trig functions. So these are the trig functions of theta. Well, let me tell you what theta is. So theta is what we call the angle. So in these diagrams, whatever this angle is right here, that's theta. So in this triangle in the first quadrant, theta is going to be this angle here. In this quadrant, this would be theta. Say in quadrant 2, this is theta. And in quadrant 4, this is theta. So theta is going to be the angle that is connected to the origin. So the six trigonometric functions of theta are defined as follows. Sine is y over r, so the y value of our point divided by r, which is the hypotenuse. Cosine is x over r, and tangent is y over x. This stands for cosecant. Cosecant is r over y. Secant is r over x, and cotangent is x over r. So do you notice any special mathematical relationship between the three sets? So here's a set, here's a set, and here's a set. Do you see any relationship between the three sets? These three sets are reciprocals of each other. So we have our three main functions, sine, cosine, and tangent, and then we have the reciprocal functions. So cosecant is the reciprocal of sine. Sine is y over r, cosecant is r over y. Cosine and secant are reciprocals of each other. Cosine is x over r, and secant is r over x. And then tangent and cotangent are reciprocals of each other. Tangent is y over x, and cotangent is x over y. Now, of course, in any of these, the denominator can't be 0 because then it would be undefined. All right, so now we're going to find the values of the 6 trig functions for each angle whose terminal side lies on the given point. So we're going to sketch out what this would look like. Okay, so if we had our x and y axis, 8, 15, they're both positive, so it's going to be over here in the first quadrant. So let's just say it's a point there. So 8 is my x value. 15 is my y value. But in order to find the 6 trig functions, we're going to have to find out what r is, which in this case is the hypotenuse of my triangle. my triangle. So to find that, we're going to use the Pythagorean theorem. All right, so let's do the Pythagorean theorem. We're looking for c, and c would be equal to the square root of 8 squared plus 15 squared. Let me change that because we're actually looking for r for the trig function, but in the Pythagorean theorem, of course, it would be c. Okay, so this would be the square root of, if I compute that, then I get 289, and the square root of 289 is 17. All right, so now we have r, which is 17, and we can find the 6 trig functions. Okay, sine, and we don't just say sine is this, the sine of theta, so the sine of the angle, again, here's theta, is equal to y over r. All right, so my y value is 15, and we just found r to be 17. So that's sine, cosine of theta is x over r. So my x value is 8 and r is 17. And then tangent of theta is y over x. So that would be 15 over 8. And of course, if our fractions can be simplified or reduced, we want to do that. Now those reciprocal functions, the reciprocal of sine is cosecant. So that's always been backwards to me. You would think that the c's go together and the s's go together, but cosecant is the reciprocal of sine and secant is the reciprocal of cosine. So just remember they're opposite of what you might think they should be. Okay, so cosecant is the reciprocal of sine, so all we have to do is take the sine of theta and flip it. So that would be 17 over 15. Secant is the reciprocal of cosine, which is 17 over 8. And then cotangent of theta is 8 over 15. And those are our 6 trig functions. Okay, so we're going to do the same thing in B. Again, this is my x, this is my y, so we need to find r. Okay, so r is going to be the square root of -3 squared plus -4 squared. Okay, so that's 9 plus 16, which is 25, and we know that the square root of 25 is 5. Okay, so that's my r. Sine of theta is y over r, so -4 over 5. Cosine of theta is x over r, so -3 over 5. Tangent of theta is y over x. Now, they're both negative, so -4 over -3 would become a positive 4 over 3. And then again, for our reciprocal functions, cosecant of theta is -5 over 4. Secant of theta is -5 over 3. And cotangent of theta is 3 over 4. Excuse me. All right, for C, we got a radical in here. This is my x, this is my y. So let's again find r. R is the square root of -1 squared plus the square root of 3 squared. So when we square -1, of course, we get a +1. And then when we square a square root, it just cancels out. So that leaves me with 4, and the square root of 4 is 2. All right, so the sine of theta is y over r. So that's the square root of 3 over 2. Cosine of theta is x over r, so that would be a -1/2. And tangent of theta is y over x. So that's a negative square root of 3 over 1, which is just the square root of 3. Let me write that a little better. All right, so then for cosecant of theta, when I flip this, I get 2 over the square root of 3. Well, we can't leave a radical in the denominator, so we have to rationalize our denominator. And if you'll remember, the way that we rationalize a denominator is we just multiply both the numerator and the denominator by whatever the radical is. So that would give us 2 square root 3 over square root of 3 times the square root of 3 would just be 3. All right, and then secant of theta, if I take the inverse of that, I would get negative 2. All right, and then for tangent, again, so this is understood to be over 1, or not tangent, for cotangent. Oh, that would be 1 over the square root of 3, but again, I have to rationalize that, and when I do, that would come out to be a negative square root of 3 over 3. All right, find the 6 trigonometric functions of an angle theta in standard position if the terminal side of theta is defined by x plus 2y equals 0 when x is greater than or equal to 0. So this is giving us just a little statement about the trig function. So we have that x plus 2y is equal to 0, and we get to choose what our x value is, as long as x is greater than or equal to 0. So we can choose any number greater than or equal to 0 to be our x value. So I'm just going to choose 2 for our x value. So I'm going to say let x equal 2. All right, so if that's the case, that's my x value. And then to find my y value, I'll plug that into this equation. All right, so if I plug in 2 for x, all right, and I solve that, I have 2y equals negative 2, divide by 2, and y equals negative 1. Okay, so that's my y value. So then to find r, again, I would do the Pythagorean theorem. So like I said, this would work. You may end up not getting pretty numbers depending on what you choose for x, but this will work for any value of x greater than or equal to 0. Okay, so let me figure out what r is. R is the square root of x squared plus y squared. So that would be 4, and that would be 1, so that's the square root of 5 for my r value. All right, so now I'm going to find the 6 trig functions. So sine is y over r, so that would be a negative 1 over the square root of 5, which we have to rationalize. If I multiply both by the square root of 5, I get a negative square root 5 over 5. Cosine is x over r, so that's 2 over the square root of 5, and again, I rationalize that, so that's 2 square root of 5 over 5. And then tangent of theta is y over x, so that's negative 1/2. And then for our reciprocal functions, cosecant of theta, so I'm going to go back to this to flip it. So if I flip a negative 1 over the square root of 5, I just get a negative square root of 5. Secant of theta, again, if I go to this fraction to flip it, I get the square root of 5 over 2. And then cotangent of theta would be negative 2. All right, so now we're going to look at quadrantal angles. A quadrantal angle is one where the terminal side lies on one of the, either the x-axis or the y-axis. So, of course, an angle of 90 degrees is a quadrantal angle, and we're to find the values of the 6 trigonometric functions for each angle. So if we have an angle of 90 degrees, they're not telling us where it's located on, okay, so if it's 90 degrees, forgive my not straight lines, then if it's an angle of 90 degrees, then we know that point P lies somewhere up here. And they're not telling us where it is, so we can choose any value to be our point P. So just to make it easy, let's just say that this is 1 unit up. So if that's the case, then my x value would be 0 and my y value would be 1. All right, so that's for this triangle right here. Okay, so it could be 0, 1, 0, 2, 0, 3, any point, and you could use, of course, fractions of numbers too. You could have it at 1.5. I don't know why you would want to do that, but I'm going to choose 0, 1 for our point that's lying on the terminal side. So if that's the case, to find the 6 trig values, or the trig functions, this is my x and this is my y. So let's find r. So to find r is equal to the square root of x squared plus y squared. Okay, so if I square 0, I get 0. If I square 1, I get 1. And 0 plus 1 is 1, so r is going to be the square root of 1, which is just 1. Okay, and that gives me sine of theta to be y over r, so that's 1 over 1, which is 1. Cosine of theta is x over r, so that's 0 over 1, which is just 0. Tangent of theta, that's y over x. Well, that would be 1 over 0, which is undefined. Then for our reciprocal functions, cosecant of theta, if I flip 1, if I take the reciprocal of 1, I just get 1. But for secant, if I take the reciprocal of 0, that puts 0 in the denominator, which makes our function undefined. Well, it's not a function, undefined. Okay, and then cotangent, this was 1 over 0. Well, now if I flip it, that's 0 over 1, which is 0. Okay, so now we're going to do angle theta in standard position with terminal side passing through -3, 0. So this would be another quadrantal angle. The point -3, 0 would be right here on the negative x-axis. So if we were to create our triangle like this, this is our x value, our y value, and then to find r, that would be -3 squared plus 0 squared, and that would give me -3 squared is 9 plus 0, the square root of 9 is 3. Okay, so sine of theta is y over r, so that's 0 over 3, which is 0. Cosine of theta is x over r, so that's -3 over 3, which is -1. Tangent of theta is y over r, that's y over x, sorry, that's 0 over -3, which is 0. And then our reciprocal functions, if I flip 0, then that becomes undefined. Secant of theta, the reciprocal of -1 is still -1, and then cotangent of theta becomes undefined. So if you'll notice, these were different quadrantal angles. They're on different axes, but all of the values end up being 1, 0, undefined, 1, undefined, 0. Then on a different axis, we have 0, -1, 0, undefined, -1, undefined. So here's a little chart that summarizes the quadrantal angles. For 0, if we have our terminal side on 0, then sine is 0, cosine is 1, tangent is 0, cotangent is undefined, secant is 1, and cosecant is undefined. That's for any point on the x-axis going to the right. The same thing for any point on our y-axis, our positive y-axis. We would have these values for our trig functions, and so on for all of the quadrantal angles. And this is going to be useful to know as we move along in trig.